Hi there. In this video, we'll learn how to graph the equation y equals negative x squared. As always, a graph's just a set of ordered pairs, and we can use the equation to decide which ordered pairs are on the graph. Something to know before we get started. To get a feel for what this equation does, let's look at what happens when x is 5. So we're looking for the opposite of 5 squared. Well, something to remember about what opposites do is that when you add a number to its opposite, you get 0. So with that idea in mind, what must be the value of the opposite of 5 squared? Well, we know 5 squared is 25. And we know when we add it to the opposite, we're supposed to get 0. So the opposite of 5 squared must be negative 25. These are the same thing. I feel it's important to point out you really must be very careful with all these negative numbers floating around, or else you'll get extremely confused. So let's compare and contrast what happens when we use the formula y equals x squared, plugging in negative 5, versus what happens when we use the formula negative x squared, when we plug in that same value. Well, in the first case, we're looking at negative 5 squared, so we have to multiply negative 5 by itself. And since it's negative times a negative is positive, the answer is positive 25. In the second problem, we're essentially doing the same math, but we're taking the opposite of that answer. Same problem, negative times negative is positive, but we're taking the opposite. So the final answer is negative 25, exactly the opposite as we got up here. Be careful. Okay, let's use this equation to generate some ordered pairs for us so we can get a feel for how that works. I'll choose 7 for x, and we'll replace x with 7 in the formula. 7 squared is 49, so the answer is negative 49. Therefore, the ordered pair 7, negative 49 must be on our graph. Let's watch what happens when x is negative 6. Put negative 6 for x. Negative 6 squared is positive 36. So the answer is the opposite of that, which is negative 36. So the ordered pair, negative 6, negative 36, is also on the graph. Notice that in both cases we end up with negative values. In fact, all the values of this function will be negative. Okay, let's generate our ordered pairs in a nice organized way. We'll write 0 and some small positive numbers, as well as some small negative numbers. Now, since this equation is almost the same as y equals x squared, it will be interesting to compare the table and the graph of y equals negative x squared to that of regular x squared. So let's start with that. 0 squared gives 0, plot 0, 0. 1 squared gives 1. 2 squared gives 4, plot 2, 4. 3 squared gives 9, plot 3, 9. Negative 1 squared is 1, negative 2 squared is 4, and negative 3 squared is 9, and we'll plot those three values as well. Okay, now we can move on to the formula we have, which is the opposite of x squared. Well, looks like we just need the opposite each of these values right here. Opposite of 1, opposite of 4, opposite of 9. So now, for example, we're looking at the ordered pair 3, negative 9. Let's go ahead and put that on the graph. 3, negative 9. 2, negative 4 is here. 1, negative 1 is here. 0, 0 is still on this graph. Negative 1 is here. Negative 2, negative 4 is here. And lastly, negative 3, negative 9 is over here. And so we get this upside down symmetrical U-shaped curve. One thing to notice by way of comparison is that these values are the same, they're just opposites. And if we look on the graph, we can see that there's a relationship there. These values are opposite, as are these. And again, there's a relationship. Up 4, down 4. Positive 4, negative 4. And lastly, 9 and negative 9 are opposites. And on the graph, we see in one case up 9, and in the other, down 9. Up 9, down 9. In fact, this graph is nothing more than a mirror image of the original graph of y equals x squared. Just to emphasize that point one more time, the graph of y equals negative x squared is a reflection of the original graph through the x-axis. Cool stuff. Thanks for watching.